lecture 3, we're going to introduce more basics about Python programming, including one additional data structure called dictionaries. And also, we will get into the idea about program control, which gives you more options about what kind of code you can write with Python. So in lecture 2, we have learned how to create variables with meaningful names, which means that those names have to be descriptive, so they have a physical meaning, and then you don't get lost in your code. And we also learned how to assign values to variables, use the equal sign. And we learned basic data structures in Python, including integer, string, floating number, Boolean, and others complex, which is not going to be the focus here. And we also learned operators that can be used to different data types. And we also tried to use Python as a calculator. And also we learned basic data structures in Python. So data structures mean that you put basic data types together, including sets, tuples, and lists, and pay attention to their differences. So in this lecture, you will learn one more interesting data structure, which is quite unique in Python, called dictionaries, and also program control using for, if, and while loops with Booleans. And pay attention to these because you will be using these a lot in future programming. So the data structure dictionaries in Python, that's a very unique type of data structure that you don't see in most of other programming languages. So dictionaries are denoted by curly brackets, which is similar to sets, but they have differences. And dictionaries are somewhat like lists, but remember that lists are indices. The indices of the lists are usually integer numbers, while dictionary, they're denoted by alphanumeric keys rather than integer numbers. So this is what a dictionary data structure look like. And for example, here I defined a dictionary called Solar Planets, and that's the name of the dictionary and denoted by curly brackets. And I have different values in the dictionary, and they are actually have two parts. One is the key, the other is the value, and separate by a column here. So this dictionary is basically a data structure that contains all the radii of the planets in the solar system. Well, some of them, right? So if you still remember the print function we used last time, so this print function basically gives me two values. One is the type of this dictionary called Solar Planets, and the second one is what's the value in the dictionary. So if you do that, and you can see that Python's telling you that the type of Solar Planet is called dict, which is a shortcut for dictionary, and also has all the values, including all the planets and their radii. So it means that Solar Planets is now a dictionary in a Python structure, Python data structure. And if you remember that in lists we use square brackets, and tuples we're using parentheses, and for dictionary we're using curly brackets. So that's the difference of how you differentiate different data types structures in Python. So to define a dictionary, if you want to type in your own dictionary, this is what you do, is that you have the syntax like this. First, you have a name of dictionary, that's also variable name. And also we put in value pairs of values, including key separated by column, and value key 1, value 1, key 2, value 2, key 3, value 3, and etc. As many as you want, right? So to access the values in a dictionary, and remember like how you look up for a word in a dictionary. So what you do is that you access the value, use the key. For example, this is quite similar to how you access an element in a list. For example, if you remember that my list 2 using square brackets, and that gives you the third element in the list because Python starts with 0 as the first index, right? So for dictionary, we use square brackets to access values from dictionary as well. For example, we do print Solar Planets square bracket with Venus, which means that I'm asking Python to print out the value that's associated with the key Venus, which is the Venus radii. So I get 6052.1. All right. So because this is not exactly a home dictionary, it's a Python dictionary. So you can change the values for a specific key. For example, which is really straightforward to do, is that I just specify a new value for the key. Here, if I want to change the Earth value to be 6,380.0, I just do solar planet Earth equals to that number. So if you do that and then print out the new dictionary, and now you can see that the Earth value is changed to 6,380, which is different from the previous one. All right, so you can also add key value pairs to your dictionary. And remember that the key and value that's called separated by a column, that's called key value pair. So for example, if I want to add Uranus and Neptune to the dictionary, what I do is simply just solar planets Uranus equals to blah blah this number, and Neptune equals to the other number, which is a very large number. So if I print out the new dictionary of the solar planets, and what I get is basically an extended dictionary with two new key value pairs. One is Uranus and one is Neptune, which is very straightforward. So you can also remove key value pairs to a dictionary, and by using the index accessing with the key. For example, if I don't like the Earth, I want to delete the Earth key value pair from the dictionary. What I do is that I just use the del function. If you still remember that, a del solar planet Earth, and then the Earth key value is gone. So there is no Earth in the solar planet dictionary. So another couple of useful methods for dictionary object. If you still remember that how we do methods on objects, so every variable or everything you work in Python is an object. So these object has their types and comes up with their own methods. For example, for the dictionary type of objects, we get useful methods. For example, keys, return the keys in the dictionary, or values, and return all the values in the dictionary. So for example, the solar planets dot keys, and that give you all the dictionary keys in the dictionary called solar planets. For example, you can see that I got Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune. And if you do solar planets dot values, and that returns all the values of in the dictionary, and that's all those floating numbers. And note that if you try to look at what the type of these, and these are basically called keys and values, they're not lists or other sets or things at all. So if you want to convert the returned keys or values to a list, and then we can use the list function we used last time to generate a list from keys or values of dictionary. For example, planets equals to list of all the solar planets dot keys, and then I got a list with all string of elements in it, and that's the names of the planets. So next, let's take a look at a basic structures of a Python code. So for example, on the left, and you see this is a simple Python code. What that code does is that asks you to input two numbers and give you your answer, which one is greater, either greater or less than or the same. All right, so don't worry if you don't understand exactly what those syntax are doing. We'll go through that later. So the idea here is that you can see that they have different parts of the code, and which are called by code blocks. For example, this is the first code block asking you for inputs. So you ask for two numbers, and the second code block does the comparison, decide which one is larger. And then the third code block prints out the results and tells you which one is larger. Right? So that's a basic Python code separated by different code blocks. So this on the right hand side is called a pseudocode, and basically it's an algorithm. So what this does is that input x and y two numbers, and then first we decide is x greater than y. If yes, and then results equals to greater than, and if not, and then you can see if x is less than y. If it's yes, then we print out less than. Otherwise, they're the same. So we set the results string to be the same as, and then we put all the results together. So this is called a pseudocode for programming. So how do we identify different Python code structures? And in Python, we use indentations. So pay attention to the indentation, which is very important to your code structure, which is different from other code languages. So Python uses indentation to define the code blocks and also makes code readable. And in the Python code, each code block starts with a condition statement, if it's true or not, and whether it's executed or not, and terminated with a column. A typical Python program would look like this. So this is just an example. It tells you that I have program statement. I define a bunch of functions, and no worry, we will go through that later. And we also had defined the code block 1 statement and whether code block 1 is executed, and these are the codes to run, and block 2 and block 3 and 4, and then etc. with a very complicated code. But you can see that the difference here is how we identify those code blocks are using indentations. All right, so a couple of rules of Python code structures is that only use spaces to indent your code. So you can use tabs, but tabs is tricky because sometimes tabs have different definitions on different computer systems. So we use one space for one type. And for the indentation, and we usually use 4 spaces, so it'll be 1, 2, 3, 4, and start with the 5th one. And a statement can be continued onto the next line if your statement is too long, and you can break it into 2 lines or multiple lines. Use the backslash sign and the same indentation of that code block. And if a statement is too short, it only has 1 line, and you can be placed in the same line as the column. So you can see that code block 4 condition statement and the block 4 statement. We will have examples of this later on. And the reserved words break, which we will see later on, breaks you out of the code block and go back to other one. For example, we have a break here. When it's done, it go back to the other or the next one. And the reserved word pass can be used to stand in for a code block by doing nothing. For example, I want a placeholder for something, so I put in a word pass, which means the code just passed through that line of code block, but not doing anything. Next, let's take a look at a basic Python code structures, which are called condition statements. So condition statements are very important, and they're used in your programs to control the flow of the execution, which basically decides how your code is going to go. So they usually include a program control statement, and as you will find out, there will be if, for, and while loops, together with relational and or logical operations. So first, let's take a look at relational and logical operations. So these are the relational operations basically uses those operators to decide the relationship between 2 values, and they usually return either false, or true, which are booleans. Right. So here are frequently used relation operations in Python. Double equal means equals. For example, a double equals b means does the variable in and equal b equal. If they're equal, then it's true. If they're not equal, then it's false. And bam equal means does not equal. For example, if a does not equals to 1, that gives you true, and otherwise it's false. So less than or equal to, and that means compares the values, the numerical values between 2 values. For example, 1 less than 2 gives true, and 3 less than 2 gives the false, and less or equal is the same. If 2 less and equal than 2, which also gives true. So greater than and greater than or equal to, they're the same as the idea as less than. It's just always compare the numerical values between the 2. So logical operators are usually used to combine 2 conditions, and they're usually working with booleans. So and means both are true, or means either is true, and not means take the opposite. For example, a and b. So a and b, if a and b both are true, then the result is true. Either one is true, either one is false, the result is false. And or means either A or B is true, then the result is true. And not means takes the opposite. If A is true, then not A is false, right? So this is a quick list of how we do the AND operation, is that if both are true, and then you got true, and if both one of them are false, and then it's false. And or is slightly different, or is that either one of them is true, and then the results is true. Otherwise, unless both of them are false, and then you got false. And not is just take the opposite. So true, not true, which is false, and not false, which is true. It's quite strange. So we have learned quite a few operations in Python, and you may ask that what are the orders of operations that when I do, like we do in mathematics. So here is a list of priorities of selected operators that we've seen in the lectures. And higher priority is 1 and lower priority is 8. So you can see that the highest priority is parenthesis, which means that whatever goes into the parenthesis, you do it first. And then next one is the exponential and followed by multiply, divide, and remainder. And then the number 4 is plus and minus. So after that comes with comparisons, which is the relational operations, and also the logical operations we just tried, we learned, and they're comes with 6, 7, and 8. So for example, for this one, and x equals 7 plus 2 times 3, and as you may learn from mathematics, and we do 2.2 times 3 first, and then plus 7. But if there's a parenthesis, and we always do the parenthesis, what's inside the parenthesis first, and then times 3. So you can see how you calculate these expressions with the priorities that's showing here with the these operators. So for example, these are actually quite complicated, but for the best practice of coding, and I would suggest you to be more specific with parentheses. Then always that we start with 2 times 3 first, and then we do the exponential one, and then we do the plus, and then we do the AND operation, which makes your programs more readable. All right, so this is a list of full list of Python operator precedents, and you can take a look at it. And some of them you may have seen it, some of them you may not, and some of these operations you will never use. But just to give you a sense of what kind of information that you can get here in the Python program. Now let's take a look at some condition statements, how we use them in the codes. So here's an example of condition statements. For example, this is a code judging you your favorite food, whether you like garlic or not. Right? For example, first of all, I define a variable called food and ask the computer asks you to give me the name of your food, and the input function basically generates a place that you can input the string, whatever. So the condition statement start with here, and pay attention to that it's called if food equals to garlic. Pay attention to double equal, which means whether it's exact same as garlic. If so, then I'm printing out I think the food is super yucky. Otherwise, print whatever put in is super yummy. All right, so that's a very simple condition statement determining which one of the code gets executed. So here's a couple of more examples of condition statements. And for example, if I'm printing out all the results here, and you can see that good equals to bad, double equals to bad, and which is false, and good is not equals to bad, that's true. And 3.14 is greater than 20, of course, that's false. And 4.5 is less than 22, that's true. And also I'm printing out Earth equals to Mars and the numbers that then the other. And remember that Earth equals Mars is false, so this operation is basically false. And also if I do or, and because the second part of the relation statement operation is true, so the results is true. All right, so think about this. What is the answer if you do Earth greater than Mars? On both sides, that's a string. Why is that? Can you figure out the reasons by yourself? All right, so the answer here is that it's not going to get you anything. You're going to get an error because the greater than operator works with numerical numbers. So these are strings, which means they don't have numerical numbers here. So you will get an error. All right, so now let's get into the details about how a if loop works, which is the first program control you will see. So the syntax of an if statement goes like this. So if a conditional statement is true, pay attention to the column and we do something. Otherwise, don't do anything, right? So in the syntax, it contains an if, which is a reserved word, and a condition statement that we've seen before. And then this is the code that gets executed or not, depending on the condition statement. Right, pay attention to the indentation, that's 4 spaces. So how the if statement works, first we evaluate the condition statement, and if the condition statement is true, and then execute the code here, do something. If the condition statement is false, and skip this do something code and move on to the next. Right, so this is a pseudocode, gives you how the if loop works. So if the condition statement is true, yes, and then do something. Otherwise, move on to the next. For example, if it's sunny today, I'm gonna play tennis. Otherwise, I'm not playing tennis. I'm not doing anything, right? So that's how the if loop works. So getting more complicated, so there's another extension of the if loop is called if-else statement. So the syntax of an if-else statement goes like if condition statement is true and do something 1, otherwise do something 2, and pay attention to the indentations and don't forget about the columns here. So how the if-else statement works. So first evaluate the condition statement. While the condition statement is true, execute the indented code called do thingy 1. Otherwise, if the condition statement is false, then execute the indented code do thingy 2. So if you look at the pseudocode, which is slightly more complicated than the first one, is that if condition statement is true, and I'll do thingy 1. Otherwise, I'll do thingy 2. For example, think about this. I'm gonna go play tennis, right? So if it's sunny, I'm gonna play tennis. Otherwise, I'm not gonna play tennis. I'm gonna go eat pie. That's all. Right, so to get more complicated, you can have more options in the if loop, and that's called if, else, if, and else statement. So it looks slightly more complicated, but the idea is the same. So the syntax of an if, else if, and else statement comes with 3 reserved words called if, elif, and else. So how does it work? If condition statement 1 is true, I'm gonna do thingy 1. Otherwise, if conditional statement 2 is true, I'm gonna do thingy 2. If none of them are true, I'm gonna do thingy 3. That's if, else, if, else. So how this statement works, first, the code is gonna evaluate conditional statement 1, and then when conditional statement 1 is true, I'm gonna do thingy 1 and then move on. And otherwise, I'm gonna evaluate condition statement 2. If condition statement 2 is true, I'm gonna do thingy 2 and then move on. If none of them are true, I'm gonna go directly do thingy 3. So if you look at the pseudocode here, and we got condition statement 1, if it's true, and do thingy 1, then move on to the next one. And if condition statement 2 is true, and then we'll do thingy 2, then move on. Otherwise, I'm gonna do thingy 3 and then move on. For example, if I wanna go to tennis or do something. So if it's sunny, then I'll do tennis. And else, if it's not sunny, it's rainy, I'm gonna go shopping. And if it's neither sunny or rainy, it's cloudy, I'm just gonna go sleep, right? So that's quite straightforward. So let's take a look at a couple of examples of the if statement. For example, the simplest one, the if and else if statement. Here I defined a number, a variable called n, and assign a value of 3, give it to it. Right, so if n is less than 0, so this is the condition statement, and don't forget about the column. and pay attention to the indentation here. And I print out n is negative, right? But when we execute this, because n is greater than 0, so this is false. So this code gets not executed. So there's no output here, right? So if we use a different loop, is use the if-else loop, and by adding the else statement here. So if else and we print out n is positive, and then we execute this, because this line is not get executed, and then we go move on to the next one, n is -3, and because now n is less than 0, and we print out n is negative and move on to the next one. So this one no longer gets executed. So the code branch in the if statement, only one code block under the if statement is executed. So the result here is n is negative. All right, so if you look at the if, elif, and else statement here, you can see that I define a variable called latitude, which is I give a floating number 22.4 here, and do it, and then I use if, else-if, and else statement to decide which region I'm in, right? For example, if latitude is less than 24, and I print out tropical region. Otherwise, if it's between 24 and 66, that's the temperate region. If none of this are true, which means my latitude is greater than 66, and then it's the polar region, right? So you can see that when I put 22.4, and the first condition statement is true, and then print out it's a tropical region, and move on to the next code block. So none of these gets executed. So the output here is the tropical region. Now let's take a look at a slightly more complicated example with the if, else, if, and else statement, and see what the pass statement can do. It's not going to do anything, right? So first let's define a list called myList with 4 elements with 4 different names: Jane, Josh, Sid, and Jeff. And for the first one that we have the if statement here is that if Susie in my list. Now here we have a new operator, which is in here, which is a reserved word of Python. So what does this in do? And also the not in here as well. So in and not in, these are called membership operators. So membership operators are used to validate the membership of a value, whether it's in a list or not in a list. It can be used in any sequence like lists, tuples, sets, etc. Right? So what this condition statement do is that it's gonna go take a look at whether the name Susie is an element of my list. If it's not, then it's not a member of this list, and it will return false. Otherwise, it's true. All right, so in this case, if Susie in my list, and you can see that it's not true, so it's not true, and then this is not going to execute it. Nothing's going to happen. All right, so the next one, if Susie is not in my list, which is true. So this condition statement, Susie not in my list, that's true, and this part of the code gets executed. Right, so it's first going to print out call Susie and apologize in this way. And then my list, I do append method, which add Susie to my list. All right, so because it's if else statement, so after this code block is executed, and we move on to the next one, because that's the same. These will not be executed. There's only one code block gets executed here. So the next one is print out the my list, which was Susie appended. Right, so you can see the output is that first we print out call Susie and apologize, and then we print out the list. And none of these gets printed out because this is done, and we move on to the next one. All right, so let's take a look at another example which has multiple else-if statements, elif. So first, let's say define exam, which is a variable, and give it floating number 80.82.0. And then we will see if exam is greater or equal to 90.0, which means that if the score is greater than this number, grade equals to A. Otherwise, we move to the next condition statement. If it's greater than 80, and it's B. So anything falling into this block is that at a grade that's between 80 and 90. And then the same idea as 70, 60, and if it's none of these applies, then it's fail. Right? So you can see that because it's 82, and then it's between 90 and 80, and this statement is true because it's greater than 80, but it's not greater than 90. So grade is now B, and then we move to the next one, which is a print statement, and your final grade is B. So that's how it's only one code gets executed in this way. The basic program control in Python is the while loop, right? So the syntax of a while loop goes like this. So while is a reserved word in Python, and then followed by a condition statement, and don't forget the column, and then while something is true, and we'll do thingy here, and then that's it. And pay attention to the indentation for spaces here. All right, so how does the while loop work? So this first step, we first evaluate the condition statement after the while statement, and if it's true, and then we executed the indented code, do thingy here, right? So one difference between a while loop and if loop here is that when this code, this do thingy here is done, you go back to the condition statement to see that condition, if the condition is true or not. If it's true, and then we do it again. And then we come back to the condition again until the condition is false, and then we move on to the next. Right? So this is the pseudocode for the while loop, how it looked like. So coming from the previous code block, we go to look at the condition statement. If it's true, we do thingy. And when it's done, we go back to the condition statement again. If it's true, and we do the same loop. So that's why it's called a while loop. All right, so until the condition statement is no longer true, it's false, and then we move on to the next code block. All right, so be careful with while loops because it's really easily that you can get infinite loops if you're not careful enough, and because the condition statement can be always true. All right, so let's take an example of a typical while loop. Right, let's use the my list we just defined before with 4 names. So while Susie not in my list, pay attention to not in, which is the membership operator. So this statement tells you Python to check whether Susie is in my list. All right, because Susie is not in the list, so this will return true. And then we move on executing the codes indented in the while loop. So we'll print out call Susie and apologize. And then we will append Susie in the list. All right, so now the list is changed because we have Jane, Josh, Sid, Jeff, and Susie, right? So after this is done, we go back to the condition statement to check whether Susie is not in the list. Now, because this time Susie is already in the list, so this will be false, right? And because this is false, we move on to the next code block, is print out my list. And you can see now we have 2 outputs. One is call Susie and apologize, executed in a while loop. The other one is the new list, which has Susie in it, right? So you can imagine that if you don't have this line of code, so for example, if we don't expand the list with Susie, and then you can see this is going to be called every time, and you get infinite amount of outputs saying calling Susie and apologize, right? That's annoying. Okay, so this while loop only gets executed once. All right, so let's take another example. So we have another example here, and we have an integer number called n, and we define another variable called threshold that's 90, n is 100, right? So let's say the while n is greater than threshold, and if n is larger than threshold, 90, and we print out n, and next time we subtract 1 from n, so n will be decreased by 1 in this case, right? So you can see that for the first step, n is 100 because 100 is greater than 90, so we print out 100, and then we change n from 100 to 99, right? So once this is done, and we go back to the condition statement again to check whether it's still true, and because it's 99 still greater than 90, and then we print out 99, and then we subtract 1, and n becomes 98. And all the way go down until n equals to 91, and then until n is 91, it's greater than threshold, and you print out 91, then n becomes 90. And then you go back to it again, because 90 is no longer greater than 90, right? Because it's greater, it's not greater and equal to. So it's no longer gets executed. So the last one printed out is 90, and then move on to the next code block and says the final value of n is 90, right? So this while loop gets executed multiple times. And pay attention to this one, that why the final value is 90 instead of 91, because every line of the code in the while loop gets executed while it's true. The next program control statement, which is probably also the most important syntax that you will be using throughout the course, is called the for loops. All right, so the syntax for for loop goes like this. With the word for, start with for, a value in a sequence, don't forget the column, and do something here. And make sure that you have the indentation, which is 4 spaces, right? So how the for loop works. So the first one is that we assigned, the first step will be assign a value, the first value in the sequence, to the looping variable. And the looping variable has a name, and you can name it whatever you want. And then do something here, and then go to the next one, and then go to the next, assign the next value in the sequence to the looping variable, and go back to step 2. And then until all the values in the list are stepped through, which means that the looping variable went through all the values in the sequence and move on to leave for loop, right? So the pseudocode looks like this. So start with the first value in the sequence, and let's see, is it the end of the sequence? If it's not, and then we do something, and when it's done, we go back to the statement and to see whether it's the end of sequence until it's done, and then we move on to the next one. That's why it's a for loop, because it can be executed multiple times. And this is actually a very important program control statement that can get you go through a lot of things in a data set. Because, for example, you have 1 million data points to work with, and you use a for loop to go through all of them. All right, so let's take an example how a for loop works, how to write a typical for loop. Right, so the for loop works very well with the range function. If you still remember that range with start included, end excluded, and step. Right, so for example, first of all, let's define a range, a variable called list called numbers, which is called range 10. So range 10 generates 10 numbers from 0 to 9, stepped by 1, because 10 is excluded. Right, so for n in numbers. All right, so now pay attention to the syntax. So n here is the looping variable, which is a temporary variable, and going through all the elements in numbers in order. All right, so for example, the first one, and the first time for loop gets executed, n is assigned as the first sequence in numbers, which is 0. Right, so now we print out 0 and 0 to the 0th order, and 0 to the 0 times 0, and 0 to the power of 0. So what you get is 0, 0, and 1. All right, so next one, this is done, and we go back to the for loop and move to the next sequence, which will be 1. Now the looping variable n is assigned as 1, right? So we print out 1 times 1, and 1 to the power of 1. And so you got 1, 1, 1. And then move to 2, and we got a 2, 4, and 4, and all the way until to the end, which is 9. Because numbers only has 0 to 9. There's no 10, right? So this is basically the output. So a for loop works very well with lists, tuples, and sets, and dictionaries. This is a very nice feature of Python, because most of programming languages has for loops as well. But lots of them, like C, Fortran, they work very well with integers. So the looping variable are usually integers, right? You go through an integer and you access something. But for loops, you can loop using anything, including strings and others, right? For example, this is another for loop. So recall we have the list called mylist with 4 names in it, and then we can do for name in mylist, right? So 2 things. One, the looping variable is called name, right? It's a temporary variable. And in my list means I'm going through all the elements in the list, right? So the first one is Jane, right? So I print out Jane here. And then when Jane is printed out, I go back to the for loop to see where name is. So where name was in the first one, then move to the next one. And now name is Josh, and I print out Josh. And then go back to the for loop. And then it's move to the third one, it's Sid, and I print out Sid. And move to the last one is Jeff, and we print out Jeff. So once Jeff is printed out, and all the variables are looped over by the looping variable, which is name. It's a temporary variable as well. So we done, and we move on to the next one, right? So here's an example of for loop stepping through the keys of a dictionary. So it's slightly more complicated, but it's actually straightforward, but you just need to get used to it, right? All right, so first of all, if you recall the dictionary solar planets, we have defined, which is the name of the planet, that's the key, and the radii in kilometers of the planet, that's the value, right? So first of all, let's print out the keys of the variables. So we have solar planets.keys. If you still remember, this method gives you all the keys, and we convert it to list, right? So it's gonna print out a list. And then the for loop here is gonna do something. All right, so first we defined a looping variable called key. And then the key is gonna step through all the keys generated by this method, right? So, and after the key is assigned, we're gonna print out this statement. The radius of planet key is the value, which is, this is how you access the value of the dictionary, which is the radii of the planet, right? So it's gonna move through Mercury, Venus, Earth, Mars, and all the way to Saturn, right? So this is pay attention to the keys. So key here is a temporary variable. It's a looping variable. And at each time the for loop gets executed, key is assigned as one of the keys in the dictionary. And then you can use that variable in the for loop. For example, here we use the key variable in the print statement, and to print out either the key or print out a value associated with the key, right? So this is the output. And you can see that first of all, we print out the list of the keys in the list. These are the names of planets, right? So then the first one is the radius of planet Mercury is 2,440 kilometers, right? So what happened to this one is that we start with Mercury. So when the first time the for loop gets called, key is assigned as Mercury because key is in the keys, right? So now we print out the radius of planet Mercury is solar planet Mercury. So remember, this syntax gives you access to the value of Mercury, right? So that's 2,440 kilometers, right? So that's everything else until everything is looped over. So the last one is key equals to Saturn, which is this one. So after key equals Saturn, and there's nothing else more to loop, and it's done, and the program is finished, right? So a couple of things to note that solar planet keys generates a sequence contains all the keys here, if you still remember from the dictionary data structure. And the variable key here is a temporary variable. It's also called the looping variable, and you can use other names as well. And the variable key gets assigned as one key of dictionary each time, and then each time in the loop, for loop, and you can use the key variable as just as a normal variable. Either use it as the whatever in what code you use, do the processing. And after the for loop is done, and the variable key will be destroyed by Python and no longer accessible. So after this line of code, and if you try to print out key, the system will tell you it's not defined. All right. So let's take a look at a more complicated loops, and this will be slightly advanced loops called nested loops, and you will use this in the future programming when you're trying to do more complicated things. So in Python, you can contain both for loops, if statements, or while loops together to make very complicated codes to do a more capable data analysis. All right, so let's take a look at an example here. So first we define a dictionary, and then we define a variable called habitable, which is false. All right. So first, let's loop over all the keys in the dictionary. So for key in Solr dictionary, solar planets.keys, and temperature will be solarplanet.key, which means I'm accessing the surface temperature of each planet. All right, so I'm converting the temperature from Fahrenheit to Celsius by doing temperature equals temperature minus 273.1. And then we assigned new temperature in Celsius to the dictionary. So we're changing the values of the dictionary every step. All right, so after we changed the temperature, we do a if loop to decide whether the planet is habitable or not habitable. Right? So the definition of habitability, is that if temperature is less than 100 degree or greater than minus 100 degree, and that's habitable, and we change the habitable to be true. All right, that's a very, terrible definition, but it's an example, right? So if it's true, and we print out planet key is habitable with a surface temperature of whatever temperature it is in Celsius, right? So, and then you print out the solar planets, which is the dictionary, right? So what happens here is that we go through all the planets and we access all the temperature of the planet using the key variable, and we convert it to Celsius. And now we, based on the temperature value of the temperature, we decide whether it's habitable or not habitable, and we change it to true. All right, so what happened here is that there's only a couple of planets that are habitable, and this is the output, right? So now after you executed this code, it tells you that Earth is habitable with a surface temperature of 15 degrees, while Mars is also habitable with a temperature of minus 60, right? For example, for Mercury, it's not habitable because the temperature is greater than 100 degrees. So this is false. And then the if statement is not executed, there's no print, right? So you only got two output from the print statement that says only Earth and Mars are habitable, right? After that, and you got to print the solar planets, and you can see what's in the dictionary. So that's everyone's get changed to Celsius. All right. So this is a nested loop, which is slightly more complicated, but you can see from a pseudocode and how this nested for loop works, right? Start from the first key in solar planets, which is Mercury, right? So is it the end of the dictionary? Of course not, it's the first one. So it's not, so we convert degrees Kelvin to degrees, and then we just decided whether it's habitable or not. If it's habitable, we change the habitable variable to be true, otherwise we change the false. Either way, you move on to the next one. So for Mercury, we first convert the degree to C, and it's not habitable, and it's false, and we move to the next one. So the next one, key, becomes Venus, and then it's still not the end, and then we do the same thing, and the next one becomes Earth, and the loop goes on and on and on, all the way to key is Saturn. And when Saturn is calculated, done, and then it's the end of dictionary, and we move on. So this is a complicated for loop, which is a good example of how data analysis is. For example, you have a list of a huge amount of data, right? So you want to decide some of the data are useful, some of the data not useful. So you loop over all the data points, and then you use an if statement to decide whether this data should be processed or this should not be processed. So this is a basic idea of how you use a nested loop.